Imagine a universe so vast, so indifferent, that even if intelligent life exists, you will never meet it. Light itself struggles to bridge the distances between stars. Civilizations rise and fall before their messages can arrive. And the energy required to cross the void is beyond comprehension. Life is fragile, space is unforgiving, and time stretches longer than a human lifetime can endure. The truth is chilling. Aliens may be out there, but contact, handshake, even a glimpse is impossible. This is not science fiction. It is the harsh reality of our cosmic isolation, and it will change the way you see life forever. The universe is not simply large in a way that our minds can comfortably grasp. It is staggeringly, incomprehensibly immense, stretching across distances that dwarf any human concept of scale. When we look up at the night sky and see stars, we are witnessing only a fraction of what exists, each one a distant sun, often accompanied by planets, possibly harboring life, yet separated from us by so much space that the distance is measured not in miles or kilometers, but in light years. The distance light travels in a single year, nearly 6 trillion miles, and even the nearest star outside our solar system lies over 4 light years away, a distance that makes our fastest spacecraft seem impossibly slow. This vastness is compounded when we consider that our galaxy, the Milky Way, contains hundreds of billions of stars, all dispersed across a disk that is over 100,000 light years wide, with gravitational forces shaping their orbits but leaving enormous empty spaces between them. And then the universe itself contains hundreds of billions of galaxies, each with its own billions of stars, expanding continuously as space itself stretches in all directions. The scale is so enormous that light, the fastest entity in the cosmos, takes billions of years to traverse some of these distances, meaning that when we observe distant galaxies, we are looking back in time, seeing them as they were billions of years ago, not as they exist today, which also implies that civilizations could exist in one corner of the universe and vanish before any signal reaches another corner. And even if intelligent life exists somewhere, it is almost certainly separated from us by vast voids of space that make direct physical interaction extraordinarily unlikely. The distances are not just numbers or abstract concepts, they define the limits of possibility, shaping what is physically achievable and what remains forever out of reach, forcing us to reconcile our desire for connection with a universe that operates on scales of time and distance far beyond human perception, where stars drift alone, galaxies rotate silently, and the notion of neighboring civilizations shaking hands becomes not just improbable, but effectively impossible because of the sheer immensity of space that surrounds us. A space that is simultaneously beautiful, humbling, and utterly indifferent to the desires and ambitions of any single species within it. The universe has a fundamental rule that nothing with mass can ever exceed the speed of light, a limit embedded in the very fabric of space-time. And this rule is not negotiable, not dependent on technology, not subject to human ingenuity. It is a law of reality itself, and it imposes constraints that are both absolute and unforgiving when it comes to interstellar travel. Light travels at nearly 300,000 kilometers per second, which is astonishingly fast from a human perspective, yet when we measure the vast distances between stars and galaxies, even light becomes painfully slow, taking years, decades, centuries, or even millions of years to traverse the cosmic expanses that separate one civilization from another. And this means that any spacecraft, no matter how advanced, would require unimaginable amounts of energy just to approach a fraction of that speed. As an object with mass accelerates toward light speed, its energy requirement increases dramatically, approaching infinity as it gets closer, making it physically impossible for anything made of matter to ever actually reach light speed. And this is not theoretical limitation. It is a consequence of Einstein's theory of relativity, which has been confirmed through countless experiments and observations over more than a century. Even if humanity were to develop propulsion systems far beyond anything we can currently imagine, capable of accelerating a ship at a sustained fraction of light speed, the journey to even the nearest stars would span decades, centuries, or millennia, raising not only technical challenges but biological and psychological ones, because no human lifespan is designed to endure such voyages, and no civilization could reliably maintain the resources and social stability needed for generations to survive the trip. Beyond the practical implications, this cosmic speed limit means that civilizations are effectively trapped within their local regions of space, unable to physically reach one another regardless of intelligence or intent. And even communication across these distances is delayed by years or millennia, turning signals into whispers that take so long to arrive that by the time they do, the sender may have long ceased to exist, and the recipient may be gone as well. The speed limit of light is therefore not just a numerical value or abstract law, it is a boundary that defines what is achievable in the universe. A cosmic reminder that no matter how advanced we become, the distance between stars and the finite speed at which anything can move makes direct encounters with extraterrestrial civilizations effectively impossible, even if we accept that life may exist elsewhere in the universe and that physical travel is theoretically possible. Another obstacle emerges that is even more subtle and insidious, the timing problem, which is the issue of cosmic lifetimes and the overlap of civilizations in both space and time, because the universe is not only vast in distance, but also vast in age, estimated to be around 13.8 billion years old. And within that incomprehensible span, stars are born and die, galaxies form and drift apart, and life itself flickers in brief cosmic moments, with intelligent civilizations emerging, flourishing, and often vanishing within spans of thousands, millions, or at most a few billion years, a time frame that may seem long to us but is almost instantaneous when measured against the age of the cosmos. And this means that even if another species reaches technological maturity capable of detecting or traveling to other worlds, it may exist millions of years before or after humanity. So the likelihood of two civilizations coexisting at precisely the same time in the same region of space is extraordinarily small. This problem is compounded by the fact that life is fragile and rare, requiring a specific set of conditions to not only emerge but survive long enough to develop intelligence and technology, and the window during which a civilization is both technologically capable and alive may be a mere fraction of a galaxy's lifetime, a blink in cosmic terms. And when one considers that stars die, planets shift, and cosmic events can sterilize entire worlds, it becomes clear that the chances of two civilizations existing simultaneously within communication range are vanishingly low. And even if signals are sent across space, the delay caused by the finite speed of light means that by the time a message arrives, the sender may have disappeared, and the receiver may be a civilization that is only just emerging or already extinct. This timing mismatch, combined with the vast distances between stars, creates a scenario in which intelligent life can exist abundantly in the universe without ever interacting, a silent population scattered across space-time, and it challenges our intuitive notion that if life exists elsewhere, contact is inevitable, showing instead that the cosmos is governed not just by physical limits, but by temporal ones, and that the emergence, flourishing, and extinction of civilizations are staggered in ways that make overlap rare, fleeting, and statistically improbable, emphasizing that the universe operates on scales that are indifferent to human desire, planning, or hope, and that the timing of existence itself is a barrier to ever meeting an alien intelligence. No matter how advanced either civilization may become, even if we imagine a civilization capable of understanding the vast distances of space and the speed limits imposed by physics, the challenge of energy and resources becomes an almost insurmountable barrier, because moving across the stars is not simply a matter of building a faster ship. It is a question of providing the astronomical amounts of energy required to propel any object to even a significant fraction of light speed. And as an object approaches these speeds, the energy demand grows exponentially, quickly reaching levels that surpass what an entire planet, or even a solar system, could sustainably provide. And this is before we consider the practical needs of sustaining life aboard such a vessel for decades, centuries, or millennia, including food, water, oxygen, and protection from cosmic radiation and micrometeoroids, all of which require additional mass and energy, creating a feedback loop where more energy is needed just to move the energy sources themselves. Even the most advanced theoretical propulsion systems, such as fusion engines or antimatter drives, face limits in efficiency and fuel availability, and the production and storage of sufficient quantities of antimatter or fusion fuel itself would demand civilizations with capabilities orders of magnitude beyond our own, requiring entire planetary infrastructures devoted solely to energy harvesting, storage, and conversion. And even if such energy were somehow obtained, the practical engineering problems of channeling it safely and continuously over the course of interstellar travel are mind-boggling. Because any small miscalculation at near-light speed could have catastrophic consequences. The issue is not merely technical, it is fundamental. The universe enforces scarcity, not abundance, and while stars radiate incredible power, harnessing it in a usable, controlled form for interstellar propulsion is effectively beyond reach, and the longer the journey, the more energy is consumed just to maintain the environment for life, protect against radiation, and correct course over thousands or millions of miles of empty space. This constraint is compounded by the fact that civilizations themselves consume resources and have finite lifespans, meaning that even a species with remarkable technological abilities may never generate enough energy to traverse the distances required, and as the distance increases, the energy demands grow disproportionately, making the dream of physically meeting another civilization across the stars effectively impossible, and even the most optimistic visions of advanced interstellar travel are ultimately limited by the immutable laws of physics and the harsh reality that energy and resources, no matter how intelligently harnessed, cannot overcome the fundamental separation imposed by the cosmos, leaving civilizations isolated, bound to their own systems, and unable to reach across the vast emptiness between the stars. Even if a civilization somehow overcomes the challenges of distance, speed, and energy, there remains a fundamental obstacle that is biological in nature, the fragility of life itself. Because living organisms are exquisitely adapted to very specific environments and conditions, and space is the harshest environment imaginable, offering nothing familiar, nothing forgiving, and nothing stable, where radiation from stars and cosmic rays can damage DNA and cellular structures. Temperatures can swing between extremes that no natural organism is equipped to endure, and the vacuum of space offers no atmosphere, no protection, and no life support, making survival outside a controlled vessel or habitat impossible. Life on Earth evolved over billions of years under the constant presence of gravity, oxygen, water, and a protective atmosphere, and even minor deviations from these conditions are lethal, so the prospect of sustaining life over the thousands or millions of years required for interstellar travel presents an almost insurmountable barrier, because any spacecraft would need to replicate these complex systems flawlessly for unimaginable durations, with every failure representing the end of the mission and potentially the end of the life it carries. Microgravity, radiation exposure, and prolonged isolation create additional challenges even within spacecraft, as humans experience muscle atrophy, bone density loss, cognitive strain, and psychological stress during long-duration missions. And scaling these effects to journeys lasting centuries or millennia amplifies the risks exponentially. And even if artificial environments or generational ships are designed, maintaining genetic diversity, reproductive health, and overall ecosystem stability over centuries is extraordinarily difficult, because small errors accumulate over time, leading to degeneration, disease, or collapse. Furthermore, life is not just fragile in its physiology, but also in its dependence on timing, resources, and stability. So any unexpected cosmic event, such as a supernova, gamma-ray burst, or collision with a rogue asteroid, could destroy a mission entirely. And the further a species travels from its home star, the greater the exposure to these unpredictable hazards becomes, creating a fragile chain of survival where a single failure is catastrophic. This biological vulnerability illustrates that even with advanced technology, intelligent life is constrained by the fundamental limitations of its own nature. And no matter how sophisticated a civilization becomes, it cannot escape the delicate balance required for life, making the prospect of surviving interstellar journeys for the purpose of meeting other civilizations effectively impossible, and emphasizing that the universe is not only vast and fast, but also profoundly indifferent to life, testing it at every scale, and reminding us that existence itself is a rare and fragile phenomenon, incapable of enduring the extreme demands of crossing the immense distances of space. Even if civilizations exist across the cosmos and overcome the monumental challenges of distance, speed, energy, and biology, there remains a fundamental distinction between the possibility of detecting signals from other worlds and the impossibility of ever meeting physically. Because communication through electromagnetic waves, such as radio or light signals, can traverse vast distances at the speed of light, allowing information to travel where matter cannot. But even this is subject to enormous delays and limitations, as a message sent from a star system thousands of light years away will arrive only after millennia, meaning that the sender and receiver may no longer exist or may have evolved beyond recognition. and the content of the communication could be unintelligible or meaningless without the proper context. Physical contact, however, imposes challenges that go far beyond those of communication, because any object with mass must obey the universal speed limit, face energy constraints, and sustain life over enormous spans of time, while also navigating the dangers of deep space, including radiation, collisions, and mechanical failure. And even the smallest error in trajectory or life support systems over interstellar distances could render a journey catastrophic. The distinction is stark. Signals can whisper across the void, reaching distant civilizations without ever leaving the confines of physics. But ships, probes, or living travelers face the unforgiving reality that distance, time, and fragility conspire against them at every moment. Even the act of sending a probe requires energy, resources, and planning on scales that stretch imagination. And while a civilization might theoretically send information encoded in light or radio waves, these signals are passive, traveling silently through empty space, while the dream of meeting another species face-to-face demands overcoming the universe itself. Moreover, detecting a signal does not guarantee understanding, because the languages, mathematics, and perceptions of another intelligence may be entirely alien. So even if the message arrives intact, interpreting it may be as impossible as meeting in person. And yet this very impossibility frames the human perspective, emphasizing that while we may be able to observe, measure, and even converse across cosmic distances, the tactile, intimate physical interaction remains a fantasy constrained by the laws of reality. In essence, the universe allows whispers of existence but forbids handshakes, permitting signals to drift across time and space, while simultaneously ensuring that civilizations remain isolated within their local domains. And it is this profound separation, the gap between knowledge and contact, between detection and encounter, that ensures that even in a cosmos teeming with life, the dream of meeting aliens physically is not just improbable but fundamentally impossible, leaving intelligent species to glimpse one another only through the faint echoes of light and radiation that traverse the endless void in the end. The universe teaches us a humbling truth. Meeting another intelligent civilization across the stars is not a matter of technology, ambition, or imagination, but a barrier written into the very structure of reality. The distances are immense, the speed limits absolute, time stretches beyond our comprehension. Energy and resources are finite. Life itself is fragile, and even the signals that traverse the void remind us of how alone we truly are. And yet, this is not a message of despair. It is a call to wonder, a reminder that life on our small blue planet is rare, precious, and fleeting. The stars above are not just points of light. They are a mirror reflecting the fragility and brilliance of existence, urging us to cherish what we have, to explore what we can, and to recognize the extraordinary opportunity we hold simply by being alive in this vast cosmos. As you leave this talk, let the immensity of space inspire curiosity, humility, and courage. Keep looking up, keep questioning, and let the universe's silence teach you to listen, to learn, and to marvel. Good luck on your journey of discovery. May your curiosity never fade. And thank you for sharing this moment of reflection beneath the infinite sky.